Algebra 2, 3-4, systems of equations. In 3 variables. So far this chapter we've been looking at systems of equations with 2 variables, some of them with not even, well, anyway, let's keep going. We're going to be doing 3 variables. So our solution is going to be x, y, z. And so this x, y, z are coordinates of a 3-dimensional coordinate plane. So, and so we're talking about planes intersecting. And so let's see what this looks like here. If I have one solution, then I might have a plane that's going like this, and then I might have another plane that's going, let's see, like this, where they're intersecting. They're going to cross each other there. And then I have another plane, so my third plane is intersecting like this. So they are intersecting right at one point. And that point is x, y, z. We might also have, well, let's look at some other ones. Infinite solutions. Where we have maybe like one plane like this, and we have another plane kind of like this, where they intersect in a line here like this. And then we have another one, this is a bad one, this is a bad example, sorry, where they all intersect in one line. So if you were looking at this from a top view, it would look like this. So we had one line where they intersect. Infinite solutions. And then another way is like if we had all 3 planes stacked right on top of each other exactly. So this would be 3 planes together. Now here are some examples where you might have no solution. So you might have a plane that's like this, and then a plane that is like this. And then another one that goes like this. So that they're intersecting in these 3 different places. So you've got 3 intersections, but they're not all intersecting together at the same spot. Another way might be if you have 2 planes like this that are parallel, and then we have another plane that intersects both of them, but these are parallel planes. Another example might be to have 3 parallel planes. those are some examples of no solution possibilities there. All right, now let's get on to some examples of how do we solve systems of equations in 3 variables. Whew. So these are these can be a lot of work. So let's just get right into it. 3x minus 2y plus 4z equals 35. Negative 4x plus y minus 5z equals negative 36. And 5x minus 3y plus 3z equals 31. So here's what we want to do. We want to eliminate some variables so that, or actually one variable from each equation here, so that we can then do our solve the system of equations in 2 variables the way that we know how before. And then it makes the whole thing a little bit easier. So what we're going to do, we're going to look at these 2 first. Yeah, let's look at these 2 first. And let's get rid of this y value. So let's go ahead and say we're gonna multiply this whole thing by positive 3. And that way we can eliminate this negative 3y. So if I have, I multiply by 3, so I get negative 12x plus 3y minus 15z equals 3 times negative 36, which is negative 108. And I leave this bottom one the way it is. 3y plus 3z equals 31. And so the y's go away, and I'm left with negative 7x minus negative 15, and 3 is 12, negative 12, equals 77, negative 77. Okay, so there's one equation. Now I need to do this one more time with these 2 so that I can get another equation that, that I can use to solve this system. So I'm going to use these 2 now, and for these 2 I can see, oh, if I multiply this one by negative 2 this time, or positive 2, then I can still get rid of this y. Notice I'm getting rid of the y here for this one, so I want to get rid of the y here for this one because I just want x's and z's. I only want to work with x's and z's. So I'm going to multiply this one by 2. So I got 3x minus 2y plus 4z equals 35. And then I multiply this equation by 2, so I get negative 8x plus 2y minus 10z equals negative 2 times 36 is 72. Okay, now I'm going to go through here. The y's go away. Negative 8x and 3x is negative 5x. And then I've got negative 6z equals 35, and negative 72 is negative 37. Okay, now I have 2 systems of equations, and not 2 systems, sorry. I have 2 equations that have 2 variables, and they are the same variables, x and z. Now I can use these to find my either x or z, and then I can plug everything and solve it. So this was kind of the hardest part, and now we do something that we've already done before, which is use these 2 to solve an equation, a system of equations with 2 variables. So let's do that and see what we can do next. So I'm going to just write these next to each other. Negative 5x minus 6z equals negative 37, and negative 7x minus 12z equals negative 77. Okay, so for this one, I see that 6 goes into 12 two times, and I can multiply it by -2 so that I get a positive 12z. So I'm going to multiply this by -2, every term by -2, and so then I get something that looks like this. -2 times -5 is positive 10x plus 12z equals positive 74. And then I just rewrite what's on the bottom there, minus 12z equals -77. And then I just go -12 and positive 12 is 0. Positive 10 and -7 is positive 3x equals -3. Divide by 3, x equals -1. Cool, am I done? No, I'm not done. But I can start my answer. I'm gonna put my answer, let's see, I don't have a lot of space for it. I'll put it right here. So my answer is gonna be -1 for my x value, and then I need my y value, and then I need my z value. Now, I'm gonna use this 1, and I'm gonna find my z value based on this, because I've got -1 for x, and so I'm gonna use one of these. I'll just do this one on the top. -5 times -1 minus 6z equals -37. All right, so I'm going to say -5 times -1 is positive 5 minus 6z equals -37. I'm going to subtract 5 from both sides. -6z equals -42. Divide by -6. Z equals positive 7. So that's my z value, so I need to put it here. So this is my x value, my y value, and my z value. So now I just need to find y. Now I can plug in my z value and my x value to any one of these and then solve for y. So let's put it in this first one. So I say 3 times -1 minus 2y, that's what I'm going to try to find, plus 4 times my z value, which is 7, equals 35. 3 times -1 is -3, minus 2y, 4 times 7 is 28, equals 35. Let's combine some like terms. -3 and 28 become 25. I'm going to subtract 25 from each side, and I get -2y equals 35 minus 25 is 10. Divide by -2. Y equals -5. So then I put -5 right here, and I am all done. Whew. All right. That is a system of equations in 3 variables. We are going to do one more of these. And this would be a u-try. 2x plus 4y minus 5z equals 18. -3x plus 5y plus 2z equals -27. -5x plus 3y minus z equals -17. And we're going to solve this system of equations. Yeah, we're going to do this. Okay, so go ahead and pause and try to work this out on your own, and then come back and see how you did. Ready, pause, go. Okay, let's start this off here. Let's do this one, these two here. Let's get rid of the z. Yeah, let's get rid of the z. Okay, so I'm going to take these two and do them over here. And when I do that, I'm going to multiply this bottom, multiply this by 2, the whole thing. So I've got -3x plus 5y plus 2z equals -27. Then I'm going to multiply all of this by 2, so I've got -10x. 2 times 3y is going to give me 6y, and then minus 2z equals 2 times negative 17 is negative 34. All right, z's go away. I've got negative 13x plus 11y equals negative 27, and negative 34 is negative 61. Okay, so there's one equation. Now I need to do another one. Let's do it over here. And that would be, I want to get rid of this z, so I want to look, let's do this one and this one. And so this time I need to multiply by a negative 5 for this one. So let's multiply by negative 5. All right, so let's write the top in first. 2x plus 4y minus 5z equals 18. Now I'm going to multiply by negative 5 so that this becomes a positive 5z and they'll be eliminated. So multiply by negative 5. Negative 5 times negative 5 is 25x. Negative 5 times 3y is negative 15y. And then I have my positive 5z equals negative 5 times 17 is positive 85. My 5z's go away. I end up with 27x minus 11y equals 18 plus 85 is 103. So now I've got two equations that each have two variables. And so now I'm going to rewrite those. 13x plus 11y equals negative 61. 27x minus 11y, oh, isn't that nice, equals 103. I don't have to do anything special. Those just get eliminated. And I have 14x equals 42. Divide by 14. X equals 3. So x equals 3. I'm going to start my equation 3, y, and z. I'm going to plug 3 back in here to find my y value. Let's do it in this one. Negative 13 times 3 for x plus 11y equals negative 61. Negative 13 times 3 is negative 39. Starting to lose my mind a little bit. Plus 11y equals negative 61. Plus 39. 11y equals 22. Negative 22. Divide by 11. Divide by 11. Y equals negative 2. There's my y value. Now I need to find my z value. So I'm going to plug that back into, I think I'm going to plug it into this top one. So 2 times x, which is 3, plus 4 times y, which is negative 2, minus 5z equals 18. This is 6. This is negative 8. Minus 5z equals 18. 6 minus 8 is negative 2. Add 2 to both sides. Negative 5z equals 20. Divide by negative 5. Z equals negative 4. So my answer is 3, negative 2, negative 4. Now, if you were to get to the end here, and you were to find something like this, where 0 equals 0, when you solve these, and you end up with 0 equals 0, 0 equals 0, you know, when you solve these systems of equations, and you end up with like 0 equals 5 or some other number, this would be no solution. If you ever get to the end and you don't have a variable equals a number, you have a number equals another number, or 0 equals a number, whatever, then if they are different, then it's no solution. If you have infinite, if you end up at the end of all of your math and you end up with 0 equals 0, 0 equals 0, and 0 equals 0, then you have infinite solutions. And that is it for 3-4. Do the homework, do a good job.